Today in this lecture video, we are going to see DT-based approach to a concept called regression, which is very much important topic in probability and statistics. So let us discuss it based on design thinking. What is design thinking actually? It is based on a user-need concept. So it has 5 stages, namely empathy, define, idea, prototype, and testing. So now who is going to explain empathy part? Yes.
Let me start with a real-time situation. Imagine you are traveling to the college every day. Some days it will take 20 minutes, and other days 40 days. Due to based on the traffic, it will changes the time. This is not your just a problem. Many people face this. Delivery company wants to estimate the delivery time. The cab drivers wants to calculate the duration. Students want to predict the marks based on the study hours. So what do users really need? Way to predict the outcomes based on the past data and in a simple and understandable way. Also, user don't want to complicated formulas. They want something practical and easy to understand understanding the problem statements. So at this stage, we understand the user problem and needs.
Now the defined part will be explained by Sire.
So let us define this problem. While defining this problem, there will be a question arised that how we predict one variable by using another variable. So let us take in real life example, like distance. By calculating distance, how do we predict the travel time? By calculating study hours, how do we predict the marks? By calculating temperature, how many the ice cream will be sold out? So these are the question arises by defining the problem. So while defining this, we need to identify the two variables. Let us take one independent variable and another dependent variable. Let us take an independent variable as x, which is input. Let us take a real life example, distance, and another dependent variable y, and it will be an output. That will be travel time. So while after identifying the two variables, there will be a problem arise that to find the relationship between x and y. So let us take an input of as x, and by taking input as x, we need to predict an output y. And this by defining this, calculating and identifying the problem leads to solution of linear regression.
So now the idea part will be explained by Saidachni.
Okay, now let's think of the possible solutions, like how we can represent the relationship between x and y. So one of the ideas is to represent the variables using a graph. Using a graph, we can track the progress of x, track the progress of y with respect to x. Let's take the sample data for distance and time. Let's take distance 2 kilometer will take 10 minutes to travel. Like that, 4 kilometers take 20 minutes to travel. If we plot these points on a graph, then we can get a straight line. So this line will represent the relationship of x with respect to y. So we can get an idea. This line helps us to predict the future values. This idea leads to the linear regression equation y is equal to a plus bx. In this, a is an intercept. Intercept is nothing but the starting or initial value of a graph, and b is the slope. Slope is the rate of change. So slope tells how much y increases with respect to x. So we can get a clear idea of solving the problem using a straight line.
Now who is going to show that?
Now we are going to see the interesting part of this prototype. Let's build our solution. Okay. First we use the formula to calculate the regression calculation. We have b equal to n summation xy minus summation x summation y by n summation x square minus summation x the whole square. For calculating a, we use the formula summation y minus b summation x by 9. Let's take an example of student study hours. Student study hours are taken as x 1, 2, 3, 4, 5 and marks as 40, 50, 65 and 70 respectively. So after calculating, we get y equal to 30 plus 10x. This means base marks equal to 30 and each extra hour adds 10 marks to the student. Now let's predict. If a student studies 5 hours, we get y equal to 30 plus 10 into 50, we get 80 marks. So the student gets 80 marks by studying 5 hours a day. So we create a work. So now we created a working model for a regression.
So testing part will be explained by a French.
So now we will be testing our model which Roshi said. So let's say that a student studies for 6 hours for the exam. So the predicted mark as the formula is y is equal to 30 plus 10x. So we'll be substituting 6 as x. So which is y is equal to 30 plus 10 into 6 which is equal to 90. So now we compare it with the actual mark. So if the student's mark is close to the predicted mark, then the model's accuracy is high and it is good. If the model accuracy is not good, and we will need to improve the model. So now to calculate the error of the model, we have a formula that is error is equal to actual price minus the predicted price. So we will be substituting the actual marks obtained and the predicted marks will be subtracted from it. So if the error is small, then the model is well and good. If the error is high, we will be need improvement in the model.
So there are few more applications where we can apply this regression. So like in predicting the delivery time of any goods, if we are ordering any goods in Amazon or Flipkart, so it depends on the distance from where it is being dispatched as well as the time. So similarly, in forecasting the sales prediction, whether it will be high or low, we can use this. Similarly, in weather predictions, stock market also we can use this regression, linear regression analysis. So we have completed one design thinking based approach to a linear regression. Have you all understood the concept?